So yesterday we did examples 1 through 7 in topic 1.3. Today we're going to just pick up where we left off and do examples 8 through 11, and then the little activity to end this off and a multiple choice AP style question. So this next part says use technology to find limits. So use a graphing utility when necessary to find each limit. So we'll need our graphing calculators today, so please make sure you have yours available. In example 8, it's asking us to find the limit as x approaches infinity of x over the square root of x plus 1 minus 1. So in all the examples we did yesterday, the graphs of the functions were given to us. This time they're not, so we are going to need to actually graph these functions. That's what the calculators are for. So we're going to graph them on the calculators and then use the graph to try to determine the limit. So I'm going to go to my calculator. And I'm going to go to my y equals, and I'm going to type in this function, which was x over parentheses, the square root of x plus 1. Make sure I go outside the square root for minus 1 and end the parentheses for the denominator. And then when I graph this, I should see a graph that looks pretty much like this one, where it starts at the point negative 1, 1, and then just curves upward to the right. So what we're looking at is the limit as x is approaching 0. So right along the y-axis, it looks like both sides are approaching the same thing, but let's zoom in a little bit just to be sure. So from both sides, it definitely appears that this is approaching the y-coordinate 2. So I can be pretty sure the limit here is 2. So I'm going to go back to my notes, and I want us to practice writing this limit expression, this limit sentence basically. So we will write the limit as x approaches 0 of the function x over the square root of x plus 1 minus 1 equals, we determined from the graph that y-coordinate the function was approaching was 2. So this is our full limit sentence. It has to have 4 parts like we talked about yesterday. First part is we have to actually say limit so that we know we're talking about a limit. The second part is the value that x is approaching. So it's the limit as x approaches 0. The third part, there has to be a function with it. So we have to be taking the limit of a function. Without a function, the limit expression is kind of meaningless. And then the fourth part is what the actual limit is. It's the limit as x approaches 0 of the function x over square root of x plus 1 minus 1 is equal to 2. So if we go to the next page, we have 3 more examples to try of functions that are a little bit more complicated. So in example 9, we're given a piecewise function. It's asking us to find the limit as x approaches 2 of f of x, if f of x is the piecewise function where it's equal to 1 whenever x is not 2, and it's equal to 0 whenever x is 2. So piecewise functions are kind of hard to graph on the calculator. This one's probably going to be easier for us to graph by hand. So we're going to make a graph. And we know something is going on at the x-coordinate 2. That's what we're approaching here. So 1, 2 on the graph. And then for graphing this, we'll look at each piece of the function separately. Let's start with this one. Whenever x is not 2, the value of this function is just 1. That's a constant. So a constant function will just graph as a horizontal line. So when we graph this, it's going to be at the y-coordinate 1, just a horizontal line anytime x isn't 2. So if x is 1, if x is 0, if x is negative 5, whatever. Or if x is 3, or x is 7, or anything. So basically everywhere except 2, we're just going to have this constant function. And there's going to be a hole in it at 2. Because even all the way up to like 1.9 is still going to be not 2. So its value will be 1. And then even at 2.1, the value of that function is 1. The only place where the value isn't 1 is right here, at exactly x equals 2. And what is the value of the function at that point? 0. So there's going to be a point at 2, 0. Just a single point all by itself there. Basically what would have filled in the hole if this was a continuous function. So now that we have graphed it, we can talk about the limit as x approaches 2. So as we trace the graph getting closer and closer to 2, what y value are we approaching? Well, it's really just staying at the same y value the entire time. So that y value is 1. So we could say the limit as x approaches 2, and again, I want you to write this in your notes. I want you to get in the habit of writing these limit expressions. For the function, in the last one we wrote out the whole function. Here we can just write f of x. You're allowed to just name the function there instead of writing the function. So the limit as x approaches 2 of f of x is 1. So from both sides, as we approached 2, the function was approaching the y-coordinate 1. All right, moving on to number 10. Number 10 is asking us to find the limit as x approaches 0 of the absolute value of x over x. So this is kind of a weird function to graph. We probably don't know what it looks like off the top of our head. So let's go back to the graphing calculator here. And we're going to graph the limit as x approaches 0 of absolute value of x over x. So coming back to my calculator, going to my y equals, clear out that last function. We're going to do y equals, ooh, I got to find absolute value on this thing. There we go, absolute value of x over x. If you don't remember where absolute value is on your calculator, you'll press math. You'll go over to the number tab, and it should be the first option there. So y equals absolute value of x over x. And I want to graph this. I want to go back and make sure my window is back to a normal window. I zoomed in a little bit in the last one, so I'm going to reset my window to be -10 to 10. And just because I know what this function is going to look like, I'm not going to set my y-axis just to be like -2 to 2, because that's all we really need to see here. So when I graph this, you can see everywhere to the right of the y-axis, this function has a value of 1. And then everywhere to the left of the y-axis, we have a function value of -1. And this is actually something that was on our pre-calc review packet. We showed that this function was equal to 1 for positive values of x, -1 for negative values of x. So what could we say about the limit here as x approaches 0? Well, because we're not approaching the same value from both sides, from the left we're approaching -1, from the right we're approaching +1, because those are not approaching the same value, the limit here does not exist. So on the graph, it looked like to the left of 0, it was at 1, or sorry, to the right of 0, it was at 1, to the left, it was at -1. So we would say the limit as x approaches 0 of the absolute value of x over x, dne, does not exist, because those are not approaching the same value. Now finally, if we go to example 11, example 11 is an even weirder one than example 10 was. It's asking us to find the limit as x approaches 0 of sine of 1 over x. And again, I have no idea what this will look like, so I'm going to graph it in my calculator and try to see what's going on there. So back to my calculator, y equals sine of 1 over x. And then I'm going to go to the graph, and my window is still set what it was in the last one, -10 to 10, and then -2 to 2. And when I look at this graph, I see almost what looks like a rational function with asymptotes, but it actually looks like the graph, I see some green here right along the y-axis. So it looks like it's dipping down and then going straight up along the y-axis to go back up to the next piece. So it kind of looks like as we approach 0, it's doing a lot of things at once. It looks like it's going down towards -infinity, But on the other side, it also looks like it's going up towards positive infinity. And then right in the middle, it looks like it crosses through the origin. So this graph is kind of confusing. It looks like it's doing several things as it approaches 0. So I'm going to zoom in to try to get a better look at what's going on. So on your calculator, you can just press zoom, select zoom in, and press enter right around the origin. Here I have a touchscreen, so I can just kind of pinch to zoom. So as I'm zooming in, it kind of looks the same as it did before. It's going, as I trace it from the left, it's going down, 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 like it's going to negative infinity, but then it shoots back up. And then if I approach from the right, it looks like it's going up to negative infinity, but it's still running along the y-axis. I'm going to zoom in a little more. Maybe we can get a little bit better picture. And as I continue to zoom in, you can see that it's not actually just starting going down and then shoots up, but it's actually bouncing back and forth very quickly. So we have all these lines in here. This graph is just bouncing back and forth between 1 and -1. So many times, an infinite number of times really. So as I keep zooming in, you keep seeing all these bounces back and forth. So what in the world does that mean then? This is a really weird function. What we're trying to answer is there a limit to this function as we get close to 0? And as you can see, we're zooming way, way in, really close to 0, and there's not actually a single value that this function is approaching. It's constantly bouncing back and forth between 1 and -1. So because there is not a value that we are approaching here, we will say that this limit does not exist, because there isn't a value that the whole function is approaching as we get close to 0. It's just going crazy around 0. So this limit does not exist. So the next part of our notes here says it's very important to understand the reasons why limits may fail to exist, and there's 3 of them. So we just looked at 2 of them here in examples 10 and 11, and we actually looked at the other one yesterday in examples 6 and 7. So the 3 reasons why a limit might fail to exist. Reason 1, f of x approaches a different number from the right side of c than it approaches from the left side of c. So that's something that's called a jump discontinuity, and happens a lot with piecewise functions. So number 10 is an example of that, where from the left it was approaching -1. Whoops. From the left we were approaching -1, and then to the right we were approaching +1. So that's an example of reason 1 here. From the left and right, the function is not approaching the same thing. Whenever that's the case, the limit does not exist. Reason 2, f of x either increases and or decreases without bound as x approaches c. So that means the function approaches either positive or negative infinity. We saw that yesterday. Down here with example 7, the function just kept going down forever. So there wasn't actually a limit, it would just keep going forever. And the same thing up here. On the left, it went down forever. The right, it went up forever. So anytime that happens where one side or both sides goes to positive infinity or negative infinity, the limit does not exist then. And then reason 3 is what we saw here in example 11 with that crazy graph. If f of x oscillates between 2 fixed values as x approaches c. So that function just kept going crazy, bouncing back and forth between 1 and -1. Then we'll say the limit doesn't exist there because it never settles on a value. It just keeps bouncing back and forth. So our activity here, in examples 8 through 11, you discovered 2 of these limits don't exist. So read this and try to figure out and fill in the blanks. You're basically saying in which example the limit didn't exist because of reason number, which of those 3 reasons. So take a minute, pause the video, try to fill in those blanks, and then press play when you're ready to check your answers. All right, so we could say the limit in number 10 didn't exist. And we kind of just talked about that was because of reason number 1, that the graph wasn't approaching the same thing from both sides of 0. And then the reason number 11 didn't exist was reason number 3 here, because the function was oscillating or bouncing back and forth between two fixed values. So because of reason 3. All right, last thing to look at today is a multiple choice question from the AP exam on limits. So the figure to the right shows the graph of a function f. Which of the following statements are true? Statement 1, the limit as x approaches 2 from the left of f of x is equal to f of 2. Statement 2, the limit as x approaches 6 from the left of f of x is equal to the limit as x approaches 6 from the right of f of x. And statement 3, the limit as x approaches 6 of f of x is equal to f of 6. So again, please pause the video, try to answer this multiple choice question, and then press play when you're ready to check your answer. So whenever I see a multiple choice question like this, I always go through and just read each statement and try to decide if each statement is true independently. I don't even look at the choices at first. I'm just going to look at each statement. So statement 1 says the limit as x approaches 2 from the left of f of x is the same as f of 2. So let me find 2 right here. The limit as x approaches 2 from the left. So I'm looking to the left of 2 at this piece of the function. Well, that limit looks to me like it's -1. And f of 2 is the actual point at 2, which that point is right here at -1. So this statement is telling me -1 equals -1. Statement 1 is true. So right away, I can throw out choice B, choice D, because those don't include statement 1. So I'm able to eliminate 2 of my 5 choices already. Statement 2, the limit as x approaches 6 from the left of f of x is equal to the limit as x approaches 6 from the right of f of x. So now we're looking at 6, and we're looking at the left-hand and right-hand limit. So if I trace this graph to the left of 6, it looks like I'm approaching -1. If I trace it from the right of 6, it looks like I'm approaching -1. So again, we're saying -1 equals -1. So statement 2 is true, which means I can throw out choice A, and that's all I can throw out right now. So it's either just those 2 are true with choice C, or all 3 are true with choice E. So we need to look at statement 3. Statement 3 is saying the limit as x approaches 6 of f of x is equal to f of 6. Well, in statement 2, we said that the left and right-hand limits as x approached 6 were both -1. That means the limit as x approaches 6 of f of x is -1. So we have -1 for that limit equals, what is f of 6? Where is the actual point at the x-coordinate 6? Well, it's down here. It's at a completely different point than this limit is. It's down at -3. So that statement is actually not true, which means the answer to our multiple choice question here is C. Statements 1 and 2 are the only true ones. So that's going to do it for estimating limits based on graphs. We'll do a little bit more work estimating limits with tables, and then you'll have a Delta Math assignment working with finding limits through both tables and graphs that you'll have due Sunday at midnight. Let me know if you have any questions, and I will see you soon.